Okay, so on to inheritance, and this will be more of the same of what we were talking about last week. I do have some minor techniques I want to discuss here. So I have a payroll program to compute employee paychecks, and here is the UML diagram that we're going to look at. We have an employee class, and the employee, this is a perfect example of inheritance because we have the generic employee class, and then we have hourly employee, which extends employee, inherits from. The arrow means inherits from. Okay, hourly employee inherits from employee. Salaried employee inherits from employee. Remember the ISA test that I talked about? An hourly employee is an employee. A salaried employee is an employee. Okay, so in the generic employee class, we have things that are common to all employees. Okay, like every employee has a name, an ID, and is going to have a paycheck amount. How we arrive at those paycheck amounts differs, depending on whether they're an hourly employee or salaried employee. So let's look at the hourly employee. What do I need to know about an hourly employee to compute their paycheck? I need to know how many hours they worked and what their hourly wage is or their hourly rate. And then the salaried employee, what do I need to know about them? Well, their annual salary, and then maybe I can just divide that by 26 for 26 pay periods. Or is that just very simple? We're not dealing with taxes and insurance benefits and all that. Just a straight calculation of the paycheck. So getting back to our employee class, this A means it's an abstract class. We have not talked about this yet. But an abstract class is a class which you cannot create objects from. Okay, you cannot instantiate that class, meaning there are never going to be just regular employees in my program because every employee is either hourly or salary. We don't have any generic just employees because how would we pay them, right? So the employee class is going to be abstract, and really its sole purpose in life is to be inherited from. It's to serve as a base class, or a superclass rather, to these other two classes, which is really where the nitty-gritty is. These two is how we're going to compute paychecks, okay? So it serves its purpose, in the inheritance hierarchy, but we're never going to have just regular employee objects. And I made sure of that by making the class abstract. All you have to, this is how you do it. You just put an abstract in front of the class name. So now if I were to try to go into main and make an employee, an actual employee object, employee E equals new employee. Uh-oh, I don't know what that was about. Let me just, okay, this will not compile. That was my AI. I wanted that back. This will not compile because employee is abstract. Okay, so I literally cannot make an employee object because it's abstract. Okay, so let's take a look at that abstract class. And we have the name, the ID, the paycheck amount, things that are common to all employees, okay? And the other two classes, the hourly and the salary, they will inherit these. You know how inheritance works now. These will also be present in the subclasses or the child classes. I've got some basic constructors, and we can still execute these constructors, in the child classes, calling the super. I overrode toString. Okay, I'm not going to get too far into the two strings. You kind of know how those work now, and this is the sample output. So the toString is printing the date and the employee name and the ID. Okay, looking at this down here. The toString is handling this part, the part that is common to all employees. And then the toString in the child classes or the subclasses will take care of the other stuff, the paycheck stuff, the money. Okay, and then I have this. This is something we have not seen. I have added what we call an abstract method. And what this means, it's called compute paycheck. Do you notice it does not have a body? It doesn't have curly braces. So it's just like a method header or a method declaration, I guess you could call that. And what does it mean when you create an abstract method? It means it absolutely must be overridden in the subclasses, in the child classes. We must do it. Okay, we're laying down the law and saying, okay, we can inherit from this abstract class, but with this abstract method, you absolutely must define a body for that method in the child classes. So, we like, for example, with toString, we don't have to override toString. We do because it's in our favor. But you don't ever have to override anything unless it's abstract, and then you really do. Okay. So, and then that's it. The rest of it is just getters and setters. So that's our abstract superclass. Let's, you know what? I think I'll end this video and then we'll look at the subclasses in the next video.